know it, that makes sense. But these you're going to use kind of in this unit and nowhere else. So I would encourage you to make sure that you have, like, pay attention to your formula sheet. Mine are done in opposite order sometimes. I think I went back and fixed them. Yeah, like, if you look at the difference formula in my notes versus the difference formula, I'm just going to use, okay, I'm just trying to find it here. If you look at the one on the formula sheet versus the one on the notes, I switch orders. This is sine alpha, cos beta, and then they go cos alpha, sine beta. I went sine alpha, cos beta, sine beta, cos alpha. It's the exact same formula, just in multiplying. It doesn't matter what order you go in, like 3 times 4 and 4 times 3 gives you the same product. So don't get bamboozled by that. The formula isn't wrong. You can use it either way. I just always go sine cos. That makes the most sense to my brain. And then I realized it's different than the formula sheet. So don't worry too much about the switcheroos about that one, because again, multiplying doesn't matter what order it happens in. So like I said, make sure you have that formula sheet. When you get your final exam, make sure you rip this formula sheet out and keep it close to you. If you're doing a sum and difference. Okay, so the reason why we would use these identities, and this will show up on your non-calculator portion. So I'm going to be honest with you, chapter 6 is probably 100% no calculator. I think on the test, I might have put one calculator question, but it's like the majority of it is non-calculator. So you're using your knowledge from your unit circle and the values from your unit circle. So again, find a way to math it out or memorize it. It doesn't matter to me which way, but you've got to make it work for yourself. I think by this point in the course and your mathematical career, you guys have a lot of good strategies. So I'm super impressed. Okay, so what's going to happen here is we're going to use a sum or difference. We're going to use a sum or difference formula to create exact values. I'm still seeing this when I marked that problem set that was epically long. Exact values, what does that mean? No calculator. Means no calculator, no decimals. Leave it as a fraction, radicals, those sort of things. So as soon as you see exact values, you know you probably should put your calculator off to the side because it's not going to help you. Or it will give you an answer, but you're going to get marks deducted because you haven't given it to me. If you give it to me as a decimal, that's not an exact value. Okay, so we are going to find on the unit circle, I don't even know where a unit circle is if I wanted one, 2 angles that will add up or subtract to give me 7 pi over 12. Because 7 pi over 12 isn't one of the unit circle values that we memorize, but there are 2 that can add up or subtract to 7 pi over 12. And there will be different answers for everybody. There's more than one way to get there. Okay, do you have a unit circle? Does anybody have a unit circle? Maybe I have a unit circle somewhere.
Memorized mine.
Sweet. Okay, well, okay, well. Here's my unit circle. Oh, here's one. Oh, this is a cool one. This is a cool one. I don't know if I ever showed you guys this one. In quadrant 1, the numerator is always pi, like the numerators, there's no coefficient on the pi. The numerator is always 1 less than the denominator. So 3 pi over 4, 5 pi over 6, 2 pi over 3. In quadrant 3, the numerator is always 1 more than the denominator. So 7 pi over 6, 5 pi over 4, 4 pi over 3. And then in quadrant 4, the numerator is always 1 less than twice the denominator. So if my denominator is 6, 6 times 2 is 12, 1 less is 11.
That makes sense.
It does.
Because if you add one more to the numerator, you'll get 2 pi.
Right, yep.
That's 2 times the denominator.
So anyway, that's a unit circle that I found. It's another strategy for memorizing, if that's helpful. That helps me. If you like this one, I can get you guys copies of it. I can photocopy it for you if you'd like a copy of it. I'll make some copies. If you have a strategy and you know this, don't feel you have to add to your toolbox, right? It's just if you're still struggling to find a way, that there's some other strategies to use. Okay, so there's my unit circle. There are no denominators of 12. But if I times denominator of 6 by 2 over 2, I'm going to get 2 pi over 12, right? If I have pi over 4, I times it by 3 over 3, I'm going to get 3 pi over 12. And then if I times it by 4 over 4, I'm going to get 4 pi over 12. So 12 you're going to see show up a lot because those ones that we've memorized all can have equivalent fractions with base 12s, or denominators of 12s. Okay. 2 that add up, I'm going to do adding first because that's probably the easiest. 2 that add up to 7 pi over 12. Okay, all right, maybe let's back this bus up. We know we have pi over 6. We have pi over 4. We have pi, I don't know why I'm having a hard time writing this, pi over 3. Those pi symbols are sketchy at best. So if I get denominators of 12, you guys would agree that that's 2 pi over 12? That one would be 3 pi over 12, and this one would be 4 pi over 12. Would you guys agree with that? Like just equivalent fraction wise? I said that as I was going around, but sometimes it's easier to see it. Now looking at those, are there 2 that add up to 7 pi over 12? Yeah. Do you guys? So those 2 add up to 7 pi over 12, right? Everybody agree with that? And again, like if you're doing a difference formula, we might have to go into another quadrant to get a subtraction one. Not a big deal, but this one works in first quadrant, so we're going to baby step it in. All right, so here we go. We know that pi over 4 plus pi over 3 equals 7 pi over 12. Do you guys agree with me with that? Yes? All right, here we go. So because we're adding, because we're looking for sign, and because we're adding, we are going to use our summative identity, so our sum identity for sign. Okay, so we're going to be using that formula right there. Because we have 2 values that add together, so right away I'm in the add, and we're looking for the sign, so I'm using the sign formula. Everybody with me so far? Okay, sure. All right, so we know that sine of pi over 4 plus pi over 3, and now we're going to fill in the formula. Let me just put the formula right underneath because like I said, I don't quite remember it. So this is your alpha, and that's your beta, okay? In adding, it doesn't really matter what order they go in. 3 plus 4 is 7, 4 plus 3 is 7. Those are communicative properties, multiplying and adding. Doesn't matter what order you do them in. Dividing and subtracting are different. Okay, so we've got sine of pi over 4 times times cos of pi over 3. So I encourage you to take your time putting it into the formula because you definitely can screw it up. So in this one, cos of pi over 4 times sine of pi over 3. So really you should have sine and cos of both angles. You should not have a double of anything. I have a sine of pi over 4. I have a sine of pi over 3. I have a cos of pi over 3. I have a cos of pi over 4. Okay? So you should have sine and cos of both angles. Okay, so take your time with that. Now, I will tell you the biggest mistake people make is that, okay, maybe I won't tell you the biggest mistake people make. We'll just keep going. I'm dropping this left-hand side now. I'm not even going to write it anymore. I still need to put my equal to sign to indicate that it is an equation. I can't lose the equal to sign, but I don't have to keep writing this because it doesn't change all the way down. Everybody with me so far here? Okay, so here we go. We are going to evaluate sine at pi over 4. Anybody? Root 2 over 2. Good job, everybody. Root 2 over 2. You've done these questions. This was your training wheels before you even knew it. You did these questions in chapter 4 or 5, where you had to find the values, plug them in, and multiply them, and add and subtract. I was training you, without you even knowing it, to do identities. So you've done these before. Shouldn't be too hard. Cos of pi over 3. 1 over 2. And if you are feeling a little less than, I'll use a mathematical term, because you're not getting these answers right away, that's okay. I'm asking you to do a lot of math all at once and to pull that unit circle to the front where we've kind of shoved it to the back. Like it's going to take some time to pull it forward. Get your unit circle out, memorize it, find strategies. The more you use it, the more practice you do with it. I know you guys don't have a lot of time in your lives. Cos of pi over 4, that's nice and easy. That's the same. So here's the thing. This is a coordinate pair. So if this one was 1/2, what's this one?
Root 3 over 2.
Root 3 over 2, right? So start making a little bit easier on yourself. Make those relationships and it should help. All right. Let's multiply. So when we multiply fractions, straight across the top, straight across the bottom, if it's a coefficient and a radical, that coefficient just goes outside of the radical. I'm not going to write it because, well, it's 1, but you could write 1 there if you wanted. And then when you're multiplying two radicals together, if they're the same index, you guys know what index is when I talk about radicals? Like they're both square roots, not cube roots or anything. You just multiply them under the root sign. How does that make you guys feel? Not too terrible? And normally we write it as one fraction, like that. This would still be correct, but this is more correct. This is more grammatically correct. Big mistake that I see happen is that people go and on this line they put cos 1/2, and that's not true. When you're evaluating cos of pi over 3, you're looking for the x coordinate, so that is the 1/2. So don't make that mistake. How does everybody feel about that? Not terrible? You guys. Degrees. I much prefer to live in radical, like I prefer to live in 1. 195. 195. Add or subtract to 195. 195 is not an exact value on the unit circle.
Quadrant 3.
It is in quadrant 3, but that's not super helpful at this point. I need you guys to think about what angles we're going to add or subtract to get to 195. Yeah.
135, 60.
135, 135, and 60. That gives me 195. So we're adding again. Okay, so we are saying 135 degrees plus 60 degrees. So we're doing something in quadrant 2. We're doing a sum identity. So because we're adding them, we go to our sum section. And this time we're looking for cos. So we're looking for the cos sum identity. So that second one right here. So we are going to have cos of 135 degrees plus 60 degrees equals, now this one is different. It's cos cos, sine sine. So cos of 135 degrees times cos of 60 degrees. And oddly enough, it's a subtract sign in this one. For summative identity, I know that messes with your mind. I have no tips and tricks on how to remember these. They're going to be on your formula sheet. I would recommend you always refer to your formula sheet. You need your degree symbols as you're substituting this in. I know, sorry, I'm writing on a curve here. I know that it's really easy to get through this and do it quickly, but please make sure you're not missing any of your degree symbols. This is why I like radicals way better. Yeah?
So on the formula sheet it says cos alpha subtract beta. How can we do alpha plus beta?
Because what did Dion pick for the two angles to get to 195? What math did we do to them? So that's why we're looking for the summative formula. Because we had to add these angles to get to 195. Yeah?
Like, is there a way of finding out, like, do we need to find the angles that add up or subtract?
What do you, yes, you always need to find the angles that add or subtract.
No, like, do we need, is there a way to find out, like, if we are finding two angles to add or we are finding two angles to subtract?
I don't understand your question. That's what we're doing.
No, so she means that if you know, like, if the question will ask us to find two angles that will add up to that we have to find.
Oh, am I going to force you to pick add or subtract in a question? No. I'm going to say cos of 195. How you choose to get there, whether you add or you choose to subtract, that's fine. It's going to be up to you. Yes, sorry, I didn't understand that question, but I got it now. I'm with you now. Okay, so again, I'm just going to drop my left-hand side. I'm not going to keep writing that. I do need to keep my equal to sign because we need to keep it an equation. So I need to go back to my unit circle. So 135, I'm looking for cos of 135. Negative root 2 over 2. So make sure that you have your negative signs in there. Because you get it, like when I do one of these questions, this question definitely, a sum or difference identity will be on, well, definitely on your test, but it will definitely be on your provincial exam. You get a half mark for every correct substituted value. So if you, like if this was a negative and a negative, this one was a negative and a negative, it comes out to positive. If you write positive, positive, even though your answer gets to be right, because these were not given in the right quadrants, you would not get the half marks for those. Does that make sense to everybody? It's like when you square something. Like, yeah, negative 2 squared is 4 and positive 2 squared is 4. I'm giving you the mark for knowing that it's negative 2. So if you do not put that negative sign in there and your answer still comes out okay, kudos to you, but you will not get the mark for that negative value. Okay, where am I going next? Cos 60. I can do cos 60. What's cos 60, everybody? 1 over 2. Sine of 135. I'm in quadrant 2, and I know my y values are positive there. And sine of 60 is going to be, these are a set, right? Like you're always finding a coordinate pair. So even if you went, I don't know if this is helpful, you go 135 and you go negative root 2 over 2 and root 2 over 2, and we know that this one is, sorry, 1/2 and root 3 over 2. Like, I don't know if that's helpful to do that, just to get your information down on the page. But if you have your unit circle in front of you, you can find them as well. So nothing too terrible here. I'm going to have negative root 2 over 4, subtract subtract positive 6 over 4. So my answer is going to be negative root 2 minus root 6 over 4.
Miss Kelly, can you say root 6 subtract root 2 over 4?
You could say negative 6 subtract root 2, but I'm not sure why you would change the order of them. Because you can't change the order of this identity. Like, don't start mucking around with the identities. Like, they're mathematical truths. Don't change the order in them. Just substitute them in. Don't get fancy. All right. Okay, you're going to try this one. All by yourself. Yeah, sorry. What? Oh, well then give everybody the answer. No? Logan's not going to share the answer. Okay, I want you guys to try this one. I'm going to do it, you're going to do it. Do you think there's any two values that are going to add up to 1 over 12 pi?
No. Yes.
No, it would be 1 pi over 12. Anything add to it? So what are you doing here for the very first time? Subtracting. Oh my goodness, you're all on your own, you're subtracting. Go back to our first question. Go back to your first question. That does not sound healthy next door. Are you guys good to see the answer? You still working?
Give me 1 second.
Okay. I'll check my phone. I want to warn you about identities in photo math. There are more trig identities out there in the world than I'm teaching you right now, and photo math is going to have access to all of them. If any of you use half identities, I'm going to know that you don't know. You know what I mean? Like if you're using something that isn't in the toolbox that we have, kudos to you if you know half identities. I mean, they're awesome. But it's pretty obvious to me when people use photomath because you end up using stuff that's out there in the world. That's a great strategy to use. But I have a sneaky suspicion none of you are learning half identities on your own time. Now that I've said that, you're all going to say that you studied up on them. Okay, I'm going to show this to you. No question, you were just smart. You guys are all very smart in here. But I'm just saying photomath may lead you down a path that doesn't make sense. And I'd much rather you actually understand what you're doing in a really difficult unit than just copying off photomath. Okay, did you guys get this? Yeah?
Yes.
Okay, those were the ones that I used. You could have used different ones. You totally could have used different ones, but you would have still come to the exact same final answer. So really important that if you are checking with your classmates on did you do it right and things like that, everybody might have a different way to get to the answer, which is a pain in my butt for marking, but still very possible. Okay, double angle identities. Life's great when you have sine and tan. Life is great when you have sine and tan because there's only one option for double angle identities. All this means is that you're going to substitute a value in here. Let's say theta is 30. So then you'd be looking for sine 2 times 30. So you'd be looking for sine of 60. You guys are like, oh, 60 is an exact value. You don't have to worry about it. Yeah, it's going to get a little bit more complicated. So especially with your proofs, double angle identities are very tricky. Sine and tan are pretty straightforward because they only have one. This is where it kicks you in the pants when in 6.3, when we're doing mathematical proofs, is cosine has 3 options. So there are 3 double identity formulas when you have cos. This is going to cause a problem in 6.3. Ladies and gentlemen, I didn't put it on the calendar, but you're going to have your first quiz on Tuesday, which is 6/1/62. Just my calendar is run out. Monday we'll do 6.3, which is proofs. So this one just becomes a little bit cumbersome. You know how I said proofs is tenacious? Like you have to try stuff, be okay with throwing it out. Like how many times have I started with double angle identity that's not suitable, and then I've had to go back and rejig it. All of them will work, but it's just how hard you have to work to it. Okay, do you guys know what cos of 120 is? You do if you have your unit circle in front of you. Okay, so we know that cos of 120 degrees is equal to -1/2. Let me put this on here. 120, cos is my x value. We know it's 1/2, correct? Yeah. Everybody good with that? All right. This example is to show you how the formula works. The next example is to show you how it's going to be on your test and on your provincial exam. I've seen these questions show up in both, well, it's on your test, FYI. But I've also seen it show up on the provincial exam. So I just want to do this one. We already know what the answer is, but we're going to do this using a double angle identity. So what angle times by 2 will equal 120? So what angle times by 2 will equal 120? You guys are telling me that it's 60 degrees, right? Yes? Everybody with me? No? That was too hard? It's okay. It's okay. We'll work through it. Okay, so we are using cos. So that means, let me get to my double angle identities. Yeah, but we're going to use a double angle identity. We're going to use a double angle identity to solve it, because that's what the example says, Rahat. So I need you to put away your phone.
So how do you start?
He's cheating. What cos double angle identity do you guys want to work in? You got 3. First one, second one, or third one? Can be any of them.
The middle one.
Middle.
Okay, I like the middle. I like doing something different. So we're going to use this double angle identity. This is the first one. This is the second one. I'm confused.
What?
It's something different, which means it's not the way she does it, so it's probably 2 times as hard.
I'm using alphas, and I really should be using, I don't know, alphas are fine. You guys know that alpha is the first letter in the Greek alphabet, and this is a lowercase alpha. Everybody knows that. If you're wondering what the Greek alphabet is, it's at the back of the room, on top of the Mondrian art, just in case you want to brush up on your Greek.
Change it up a little, yeah. English alphabet.
No, we need the Greek. All right, so we know that we are, what is our angle that we're using? What's alpha? 60. All right. So we're going to evaluate sine of 60. What is sine of 60? Are you sure?
I'm staring at it.
Are you staring at it right now? So that's going to be root 3 over 2. The squared goes on the outside there. So we evaluate sine of 60 and then we square it. We're not trying to figure out what the sine of 360 is. Everybody understand that? So you evaluate sine of 60 and then you square it. But you guys know this all because you've already done it. So what's 1 minus 6 over 4, which is really 3 over 2? Let's see if you can do some fractions in your head.
2 over 4.
What kind of half?
Negative.
What kind of half?
Negative.
Negative.
It's just equal.
Well, I hope you guys all knew it was a negative 1/2, because didn't we know that as an answer anyway?
Yep.
So if you reduce this, this would be 1 minus 3 over 2. I know 3 over 2 is negative, or is 1.5. 1 minus 1.5 would be negative 1/2. That's some basic mental math there. Okay, here we go. This is a question that you will get on your test for sure. Or a variation of this one, not exactly, but a variation of this one. So this is a double angle identity. It says that cos of pi over 20 has a value of 0.99.
Why?
I don't know.
It's just the way the
This would show up on a non-calculator portion. Because if you had your calculator, you literally could just do cos of pi over 10. Do you know what I mean? Like this is on the non-calculator portion of your exam. So this is how we would solve it. Do you see a relationship between this angle and this angle? And let's say the word double? Because if we double this, isn't it that? Would everybody agree with that? If I times this by 2, doesn't it give me that? Do you guys see that?
Yes.
Did that leap off the page to you?
No.
If you get a question like this, I think I would remember the word double. Okay? I think I would just remember that word. Just throwing it out there. So we know that 2 times pi over 20 is equal to pi over 10. Everybody good with that? So as soon as you see the word double, or as soon as you times by 2, I'm just writing the word double there because we never say double in math. Like we say like times by 2. by a factor of 2, right? Like increase by a factor of 2. If I'm doubling it, then I'm going to go to a double angle identity. Now, I'm going to have to be very purposeful with the cos identity I pick here. Because all I know is cos is equal to 0.99. If I pick the formula that we just used, do we know what sine of pi over 20 is? We do not. So right away, I know I can't use this formula because I can't evaluate sine of pi over 20. Can I use the first option? No, because it also has a sine in it. What's the only one I can use? The third one, because it's the only one that just has cos in it. So I have to be purposeful with the one that I pick. Now, this could have switched. This could have said sine of pi over 20 is equal to something. Then we would have been purposeful in picking that second one again. What? Where'd I get what page? It's the pink page sitting in front of you, bud.
Oh,
Okay. All right. So I have to, so sometimes you can use any of them, and then sometimes you have to be really purposeful in which one you use. So we're going to use cos double angle alpha of 2 cos squared alpha minus 1. How do you guys feel about alpha? How do you feel about the fish?
Is it okay if you insert alpha for A?
That's not very creative. Could you use A? Could you use X? Could you use theta? Absolutely, you could. It's always good to expand your horizons. And no? No expanding? Just want to live in the little bubble you already know? Okay. It's just a variable. Just like theta is a variable. They use alpha and beta a lot in trig identities because we can't use theta and theta. Because if you use theta repeatedly, that means the angle's the exact same, and that's not true. So they use the angles alpha and beta just to indicate that those alpha can be one thing, beta can be something different.
But they don't actually mean a specific anything.
They don't mean a specific anything, just like theta doesn't mean a specific anything. Okay, so we're going to go cos of 2 times pi over 20. No chance of finishing the lesson?
Kind of like infinity pages long.
Is it? Nah, we're good. We're good. I'll probably skip one of those anyway. Then you know what? Then you're just gonna have no clue what to do, and there'll be tears, and it'll be bad.
If it wasn't for Dion yesterday.
Yeah.
Only what that right now.
Oh geez, sorry, that 2's not there.
How could we like find this without?
They would be much nicer numbers, and it's probably going to be into a sum or difference identity.
So we wouldn't have to like 0.99?
No, you wouldn't have to, like it might be equals to 0.3 or something like that, or 0.35, right? 0.35 times 2, I think you can all handle that. Can you all handle 0.35 times 2?
I mean, I could handle that, but that sounds a bit too.
What's 0.3 squared? 0.09.
Wait.
Okay.
I was supposed to do this without a calculator.
No.
You can't
No.
use calculators?
This one would be a calculator, but you'll see this type of question
Without a 0.99.
without a 0.99, without something as complicated. Maybe a single digit decimal. You should be able to deal with that. Okay. All right. This is a question. It's a 1-mark question, maybe on your test. And I've seen it pop up on the provincial exam before. Can you guys write that as a single trigonometric function? What I want, this is a matching question, folks. This is a matching question. I want you to take this, and I want you to take this, and I want you to figure out what left-hand side does it match.
Miss Kelly and I, Miss Kelly.
What?
What's the clock over there?
Oh, the battery died.
It's been dead for like 2 years.
I know. I don't know why it came down. It just showed up on my desk one day. It was somebody's idea to like push me to get a new battery, and so now it's just moved over here.
Then Miss
And I
Kelly,
haven't
how
committed
are
to
we
getting
gonna
a new
rank
battery.
you then?
Is the sign difference?
I don't know.
Miss Carol, is the sign difference?
Sign?
It is.
Sign
Back
difference?
that one.
It's a sign difference one? You guys would agree? Okay, so let's do this.
It's the first one.
So you guys are telling me it's this formula here. You guys are telling me that it's this formula here.
Indeed.
So you were telling me that alpha is 48, and you're telling me that beta is 17.
Correct.
You are correct. I'm correct. You're correct. We're all correct. So we are going to write this as a single trigonometric function. So sine 48 degrees minus 17 degrees. What do we get? Sine of 31 degrees. Ta-da! You wrote it as a single trigonometric function. So looks really complicated, but really it was just matching it up to a formula.
Miss Kelly, grade 12 just absolutely destroyed my love for trigonometry.
Oh, I'm sorry to hear that.
I used to love trigonometry.
Okay. Single trig function. Single trig function. Another matching question.
So we're gonna have the machine and then. This
Yeah.
looks like cos, double angle cos, the first one.
Yes.
Miss Kelly,
Double angle cos. First option.
cos 2a equals to cos alpha.
Yeah, we're there already.
Yeah, I got that in your Get off.
You know, shut up, Logan.
Please.
They almost told me no.
Okay, please be kind to each other.
And a little bit of improvement. And gone. He's gone. He hates my superior.
Okay, so that's that one. So we would have cos 2 of pi over 12. So that would be cos of pi over 6. I'm just switching it up because I can.
So strange.
Why do the lessons have, like, the chapters nowadays have long
900 lessons in them. It's what I'm going for.
No, but they got really long lessons, but short.
You got your mind on this.
All right. Okay, let's move on. So I'm not traumatized. You're not traumatized. Okay, little bit of trig identities in here. Little bit of yesterday's lesson. I'd like you guys to simplify this expression. Maybe it's a foreshadowing for tomorrow. Or Saturday. We're all coming in and doing proofs. Yeah, we all signed up for it.
Wait, what?
You were away flitting around doing concerts and things like that. No, Monday. I'm just so excited to teach 6.3. It's my favorite lesson. Okay, start substituting in. I'm going to use an erasable pen for this one.
What?
Which one do you want to try? Maybe let's do the denominator first. Sine, because we only have one option. 2 sine x cos x. That's all we can do for the double angle identity. All I did was replace sine double angle with its expanded right-hand side from the formula sheet. Okay, Rahat, I'm guessing you're not looking at your unit circle now. So which cosine do you want to try?
I don't know. Which one?
Yeah, we're going with the second one again? Okay, So we have 1 minus, I'm going to use brackets here just because hopefully it will be a little bit helpful. 1 minus 2 sine squared x. You don't get what?
How do you get the sun?
What? How did I get this one?
Yeah.
We picked that one.
Oh.
That's like we just took a random guess. Like there wasn't any thought or reason to it. We just said we're gonna try this one. Okay, and that's all we're doing at this point. Non-permissible values. What can sine and cosine not equal? 0. So where is sine 0? At 0. Yeah. So 0 plus pi k, where k is an element of the integers. And where is cos 0? Pi over 2. Okay, so there's your non-permissible values done, kind of out of the way. Sometimes you know how we say step 1 factor everything? Almost in trig identities, you have to expand it. I don't know if that makes sense. Like change it to a different identity to see it. Okay, here we go. Ta-da! Now we're going to do some mathing. We're going to simplify this. So 1 minus 1 plus 2 sine squared x. Everybody know what I just did there? I just distributed the x, or the negative through. Everybody good with that? Okay, you need to be working on this and not doing past assignments. So don't get up to put it in the bin. Rahat, was it you? Was it you? No, because you are on your reels. You don't have time to do past assignments. You're barely, like, there's internet to watch. Internet to watch. All right. It was a good pick for you guys. It was a good pick for you guys. What happens to those 2's? Cancel each out. What happens with the sign on the bottom?
Cancels 1 out.
Cancels the squared out, right? So that's going to leave me with sine x over cos x.
Oh my goodness.
Look at us. You've just done 6.3. You've done an identity. Well, kind of. You've done half an identity.
Now we gotta solve it.
So isn't that awesome? Like how you can take it, make it look like something else? No?
Yeah, it is awesome if only I understood how.
You don't understood how we did that?
I do. Sort of. Just lying.
Do you guys get this one?
Yeah.
Because really that's like saying sine x times sine x.
No, I guess.
So, ladies and gentlemen, I don't usually write it out in expanded form. I just usually take that out and take out the squared. But this is actually the stuff that's happening on that step, just in case you're... So we picked really well. Good job, you guys. Good job, Maya. Good job. Gold star. All right, guys. This will definitely be on your quiz, be on your test, on the exam. And I would say that this is probably what my students struggle the most with. So here's the thing.
Just put down the book.
This question, you do not have to solve for the angles. This will be on your non-calculator portion. This, you can answer. You have all the information that you need there. And if you have Pythagoras, you also know that as well. All right. So what you have to do is you have to create pictures for all of these. Now, pictures. You're going to draw me a pretty picture.
Miss Galley, every second the class seems to go very.
We're going to get through this one, and then we're going to pause for today. All right. What quadrant am I in? What quadrant does this restriction tell me I'm in? 2. So that's telling me I'm in quadrant 2. So angle A is somewhere in quadrant 2. That's all we know. So here's your pretty picture, ladies and gentlemen. You know you're in quadrant 2 somewhere. We know alpha is made right there. Can you fill in the triangle?
Yes.
What's the hypotenuse?
1.
Hopefully it's 5.
Shut up.
Because you're basing it on this information here. Is my 5 the positive or negative?
Positive.
Has to be positive because it's the hypotenuse of the triangle, and we would be squaring it. Cos, so this is going to be -4. What's the height of this triangle? 3. You know your Pythagorean triples. Good job, everybody. If you didn't know your Pythagorean triple, use Pythagoras and solve for it. So again, these ones aren't going to be hard numbers, or you're going to leave them as radicals. Don't overthink it. So what do we know? Do the trig ratios. Sine of alpha is equal to
3 divided by 5.
3/5.
So if there's a variable in the question, do we have to use that when stating the answer?
Yes.
Oh.
That would be an E3 error if you use a different variable. You've introduced a new variable without defining it. Okay, so now you're going to draw me a second pretty picture. For beta. Where's beta?
Quadrant 3.
Okay. So what do we know about this one? We know the hypotenuse is 13. We know the x is -12. Another Pythagorean triple here. Anybody know this one? 5. But it'll be -5 because where we're located. So we know that cos is -12/13. We know that sine of beta is equal to -5/13.
Why are we looking for some?
Because the question's asking us to use cos alpha minus beta. And if we look at cos alpha minus beta, if we look at that identity, it has cos cos and sine sine. So we need the sine. Did we need to find tan? No, because there's no tans in this. If you found tan, proud of you, we just won't use that information. All right, so that's the next step of this. It's asking you to solve cos alpha minus beta. So we're using this identity, cos cos plus sine sine. So we are using cos alpha minus beta. So we have cos of alpha times cos of beta plus sine alpha times sine beta. All right, this is where I said you do not need to solve for the angles. People somehow freak out. They think that they can't do it without their calculator. You totally can. You guys had no problem when I told you the angle was 60. You had no problem substituting in the value for it. You know what cos alpha is. It's in the question. Cos alpha has a value of -4.5. So we're replacing cos alpha with -4/5. Cos beta we know to be -12/13. Okay, so we already know these values. This is where people, they end up putting the -4.5 in for the angle, and that's not a true statement. Cos alpha is equivalent to -4.5, so we're taking out the whole cos alpha. I keep saying 4.5, 4/5. So you take out the cos alpha, replace it with that. So now you know your signs, 3 over 5 and negative 5 over 13. Okay, can you do this math in your head? Probably. What's,
No, 13's a weird.
okay, but what's 5 times 12? 5 times 12 is 60. So what's one more? 65. Right? So take what you know and do that. Now, these are going to be negatives. So all of that we did without a calculator, and that's not out of the scope of your skill set, okay? All right, I said we'd stop here. This is a long lesson. Nothing really, like it's just one more example, so nothing really too different. You can definitely do this lesson without having this part in it. I'll do it Monday morning, or I'll do it Monday morning before we start 6.3. But you can do this lesson. Please don't say, oh no, I can't do this lesson. We didn't do the last example. It's exactly like this example. So you could even try it on your own, you wild and crazy kids.